The slope of a line. My name's Tuesday J. Johnson. I'm an assistant professor at Doña Ana Community College and a lecturer at the University of Texas, El Paso. This lecture is for Math 120 Intermediate Algebra at DACC, also at New Mexico State University. Chapter 3, Linear Equations in Two Variables and Functions, comes to us from the XYZ textbooks. This one written by Turner McKeague. It's their first edition of Intermediate Algebra. Section 3.2, the slope of a line. So, again, unabashedly, I'm taking images directly from the text, so thank you to Mr. McKeague and his publishing company here. A line with a positive slope rises from left to right. So a positive slope, you're going up, it rises from left to right. Whereas a line with a negative slope is going to go down. It's going to decrease. It falls from left to right. Zero slope, you're in snowshoes here, or cross-country skiing. It's a flat line, zero slope, no tilt to it whatsoever. Your car shouldn't roll if you park it without the emergency brake. An undefined slope, I like to think this in terms of skiing. If you try to ski down something vertical, I've seen the fail army videos. This is where you die. You are undefined. Don't ski down vertical cliff faces, people. Undefined slope for a vertical line. So what is the slope? How do we find the slope? Once again, I took this image directly from the text. And the instructor resources have these. It's nice. The slope of the line passing through the points x1, y1 and x2, y2 is given by this formula. The slope is equal to m. M, we frequently call it rise over run. This is our geometric form. That's how we can visualize it. Algebraically, that is y2 minus y1, so the difference in the y values, divided by the difference in the x values. Keep in mind that fractions have numerators and denominators. Alphabetically, denominator comes before numerator. Alphabetically, x comes before y. But if your fractions don't have numerators and denominators, and your fractions instead have tops and bottoms, notice that bottom still comes first alphabetically over top, x still comes first alphabetically over y. Keep the order straight. It matters that it's rise over run. It matters that it's y over x. So what is this y2 minus y1? It's the full height y2, and then I subtract off this little part, so I have the distance between them. Subtraction is going to be the distance between them. So let's look at some examples. If I have a point right here, 0, negative 3, how do I get to another point on the graph? I could go up 3 units, and to the right 2 units. Up 3, that's a y value, that's plus 3. To the right 2, that's an x value, that's plus 2. My slope is 3/2. In example 2, from a point in negative 3, I can go up 3, and then to the left 2. And that, look at me talking all out the side of my mouth here, I could go up 3, and to the left 2, or I could have started here at negative 2, 0, right 2, down 3, right 2, down 3. Notice that's negative 3/2. Notice if you go up and left, it's also negative 3/2, so it doesn't matter which order you go in. Example number 3 is a vertical line, so I know that's an undefined slope. Don't ski off of that. Be safe. Horizontal line. Nice flat surface. Your car's not going to roll. That's a 0 slope. When finding the slope between 2 points, I made a bit of a mistake here. I always should start with the leftmost point first. And the nice little leftmost point here at 1, 1. From this point, I can go up 2 units, and to the right 3 units. Plus 2 plus 3 gives me 2/3. And so what's going on here, let's see if yellow works for us. I'm going to take this point and go down 2, make sure that's negative, and to the right 1, 2, 3. So my slope is down 2, to the right 3. My slope is negative 2/3. It's negative because it falls from left to right. Example 2 falls from left to right. It's also a negative, whereas 1 and 5 are positive slopes. Alright, so using the equation, find the slope of the line through each pair of points. Plot each pair of points and draw a line through them, indicating the rise and the run in the graph. If I'm given a 3, 1 and 5, 6, my slope formula says I subtract the y values, so 6 minus 1, and then I subtract the x values in the same order. So we can see here 5, 6 is a point, 3, 1 is a point. They're matched up together, so 5 minus 3, because I started with the 6, I have to start with the 5 in my subtractions. 6 minus 1 is 5. 5 minus 3 is 2, and if I plot these points, 3, 1 and 5, 6, you can see that I have gone to the right 2 units and up 5. That's exactly what my slope indicates. 1, 3 and 5, 2, I'm going to subtract 2 minus 3, 5 minus 1. 2 minus 3 is a negative 1, 5 minus 1 is 4. What did I do? I went down 1 and to the right 4. That's exactly my slope, and it matches up with my graph. Negative 3, 2 and negative 1, 6. I'm going to subtract 6 minus 2. In the denominator, keep my order, negative 1 minus a negative 3. That's 6 minus 2 over negative 1 plus 3. 6 minus 2 is 4. Negative 1 plus 3 is 2. And I could simplify that to be 2 over 1. And yeah, I know that's 2. But 2 is not very helpful. When it comes to slope, I like to leave it in fraction form. That way I could see the rise and the run in the graph. If I graph these at negative 3, 2 and at negative 1, 6, not only can I see I go to the right... I wrote these wrong. Yep, that's a 2 up here. We can't necessarily see it. I see what I did. I didn't do it wrong. Look at that. So if I go over 1, I'll go up 2. To the right 1, up 2. Or if I go over 2, I'll go up 4. Whether I simplify the fraction or use it as a 4 over 2, either way, it's still going to be on the line. So I know another point on this graph, just by using my slope, I know that if I go to the right 1, I'm going to be at a y value, or an x value of negative 2. Right, to the right 1, up 2. So from 2, if I go up to the point negative 2, 4, is also on my graph. Right, so the slope in reduced form or non-reduced form, it doesn't matter. You're still going to find points on your graph. Find the slope through the points. If I have 2, negative 3 and 2, 7, I subtract 7 minus negative 3, and I subtract 2 minus 2. That's 7 plus 3 over 2 minus 2, which is 10 over 0. We cannot divide by 0. A good rule to follow is, if you have a fraction, when the 0 is in the denominator, no, you can't do that. That's undefined. So if it's an undefined slope, we automatically know it's a vertical line. Every vertical line has the form of x equals. What is x? Oh, it's 2, repeatedly. So x equals 2, the equation of our line. Given the points negative 5, negative 2, and 4, negative 2, I could do negative 2 minus a negative 2 over 4 minus a negative 5. That's negative 2 plus 2 over 4 plus 5, which is 0 over 9. 0 over 9, that's all right. We'll use green for this. 0 in the numerator, that's okay. That's no problem. 0 in the numerator is cool. 0 in the denominator, no. We cannot have that. So we have a slope of 0, which tells us this nice flat surface. It's a nice flat surface. It's a horizontal line. All horizontal lines are of the form y equals. What is our y value? Our y value is negative 2. That's it. Don't overthink it. All right, so two non-vertical lines are said to be parallel if their slopes are equal. So literally equal, the same thing. Two non-vertical lines are said to be perpendicular if the product of their slopes is negative 1. So if you multiply the two slopes, values of the two slopes together, you get negative 1. Or if I want to solve for m1, I can divide both sides by m2, and we could say that one slope is the opposite sign and reciprocal of the other. So I'll use opposite in terms of sign and reciprocal a lot of times for my perpendicular lines. Alright, so determine if the lines through each pair of points are parallel, perpendicular, or neither. Here I have the points negative 2, and 4, 4. I can find the slope of the lines between slope of the line connecting them. 4 minus a negative 2 over 4 minus a negative 2. Y minus y, x minus x. That's 4 plus 2 over 4 plus 2, which is 6 over 6, which is 1. Okay. Then I have the points 1, 5, and 3, 3. I'll do 3 minus 5 and 3 minus 1. 3 minus 5 is negative 2. 3 minus 1 is positive 2. Negative 2 divided by positive 2 is negative 1. Now, I know that these are perpendicular because 1 times negative 1 equals negative 1. The product of the two slopes is negative 1. Given the point 3, negative 6, and another point, negative 1, negative 3, I can find the slope. Negative 3 minus the negative 6, subtract the y values. Negative 1 minus 3, subtract the x values in the same order. Negative 3 plus 6 is 3. Negative 1 minus 3 is negative 4, so a slope of negative 3/4. For the other 2 points, negative 5, 6, and 3, 0, I'm going to subtract the y values, 0 minus 6. In the same order, I'm going to subtract the x values, 3 minus a negative 5. That's 0 minus 6 over 3 plus 5, which is negative 6/8. And we'll always reduce our fractions to lowest terms. Negative 6/8, if you factor out a 2, cancel it, you'll have negative 3/4. Whether the negative is in the numerator or the negative is in the denominator, it makes a negative fraction. These two lines to the given sets of points will be parallel because both slopes are negative 3/4. Alright, now I already know this is going to be neither because we have 3 choices, parallel, perpendicular, or neither, and I'm going to give you 3 examples, but let's see why. No cute little color coding here. We're just going to subtract 3 minus 0 and 7 minus 2 to get our first slope of 3/5. We're going to subtract our y values, 2 minus a negative 1 over negative 4 minus 1 to get the slope of the line through the second set of values. That's 2 plus 1 over negative 4 minus 1, so that's 3 over negative 5. My solution simply says neither. But why? Well, they have opposite signs. So both of them are 3/5. We're thinking parallel, but one's positive, one's negative. They're not exactly the same. They can't be parallel. So they have opposite signs. Maybe they're perpendicular. But they're not reciprocals. Neither one is a reciprocal of the other one. If you multiply these together, you get negative 9/25, not negative 1. So they're not reciprocals. They're not exactly the same. Therefore, they are neither parallel nor perpendicular. So let's suppose this line L contains a couple of points, 6, negative 3, and negative 2, 7. I want to find the slope of any line perpendicular to L. Well, I can find the slope of this line. I'm going to take 7 minus negative 3, and then negative 2 minus 6. That becomes 7 plus 3 over negative 2 minus 6, which is 10 over negative 8. They both have a factor of 2, so that slope simplifies to negative 5/4. The perpendicular slope will always have the opposite sign, so it'll be positive, and it will have the reciprocal. The reciprocal is we flip over the fraction. So the line perpendicular to negative 5/4 will have a slope of positive 4/5. Let's take a look at a little word problem type of thing using slope. An object is traveling at a constant speed. The distance and time data are shown on the given graph. Use the graph to find the speed of the object. And my thinking is this: speed is a rate. I know that I have distance and time data, and I know that distance equals rate times time. I call this the DIRT equation, D, and then I for is, right, equal sign, D-I-R-T. So my speed, my rate, is going to be distance divided by time. I could take any 2 points. I could use the point 2, 35 and the point 0, 0. The change in height, I'm going to go a right 2, up 35. So 35 halves, 35 halves, 35 halves, or 70/4, or 105 divided by 6. Either way you look at it, that fraction simplifies to 17.5 miles per hour. That's right. Slopes actually have something to do with real life. Who knew? Thanks for listening.